Now I've got several examples of indefinite integrals of type 1. That is, integrals over an infinite area. So here's the first example. This is a classic example that you should be able to do quite quickly, right? Because what we see here for this integral, 16 plus x squared plus a squared, in the bottom, that's inverse tan, right? So you can change variables, or you can just go ahead and use the form that's on our chart, which is going to be, this is a squared, so a is 4. I've got 1/4 inverse tan of x over 4. Evaluate from 0 to t now. So what I have here is limit as t goes to infinity of 1/4 inverse tan of t over 4, okay, minus 0, right? Because inverse tan of 0 is 0. So as t goes to infinity, t over 4 also goes to infinity, so the 4 in here doesn't really do much in the limit. And what happens to inverse tan in the limit as t goes to infinity? Well, if you remember what the graph of inverse tan looks like, it has those two asymptotes, the pi over 2 and the minus pi over 2. Minus, you can't tell. All right, how about this? Minus pi over 2. That looks a little bit better. All right, and then this graph goes like this. So just sort of remembering that, as I'm going out to positive infinity, I'm reaching pi over 2. If this integral was different and I had a negative infinity, I would be going out to negative pi over 2, right? So as I get that, and that's just important to know, you can just, when you see that inverse tan, we can just evaluate that limit there. So this is going to be pi over 2. So my answer for this integral is pi over 8. Okay, and using the graph is perfectly acceptable in this way because that's a known limit. So sometimes we have to do more work to evaluate the limit, but sometimes it'll turn into something which is just basically some known limit, right? So that's why I'm saying great time to look back at those limits and make sure that you understand how to do the limits at infinity. And also, we'll see for the type 2 integrals, limits where you've got a asymptote and such. Okay, a vertical asymptote. These are all going to be more like horizontal asymptotes, right? Because we're going out to infinity. So here I've got the infinity as the lower limit. Not a problem. I do exactly the same thing. I just call it t. Now t is going to negative infinity. Some people might take t to go to positive infinity and call it minus t here. That's fine too. If you prefer doing it that way, it's quite okay. And this integral here also is an easy integral because I break this up, right? So I can break this up as 1 over x plus 1 over x squared. And now these are sort of familiar from a previous example. In any case, these are easy integrals to do. So let me write it here. This is going to be natural log of absolute value of x minus 1 over x, right? And then from t to negative 3. So now if I evaluate this guy at those limits, I'm going to have natural log of 3 minus 1 over minus 3, and then minus natural log of absolute value of t, and then minus and minus is plus 1 over t. Okay. So now I've got some numbers here. Now when I evaluate this as t going to negative infinity, it's going to negative infinity, but it's absolute value of t here. So this is going to positive infinity, right? Natural log going to infinity is infinity, right? If I look at natural log, right, it does that. So this guy is going to negative infinity, and this guy is going to 0. Well, so the whole thing is going to go to negative infinity. So honestly, what do I have? I've got these numbers here, minus infinity plus 0. So this whole thing is going to diverge. It's going to go to negative infinity. This is ln of t here. That's what I was drawing. Okay, so once you have a piece like that is going to infinity, like this is going to take the whole thing to infinity, right? Because this isn't doing anything. That's just going to go to 0. All right, I think I've got 2 other examples. They may be a little bit longer, so I'm going to put them in a separate video.